So welcome to the class on probability distributions. Here we are going to see mainly binomial and Poisson's distribution. So we will start with binomial distributions. So binomial distribution is based on binomial theorem. That is, what is the binomial theorem states? Say for example, if I have P plus Q, P and Q are something, don't worry what is P and Q. P plus Q power n is defined by binomial theorem as what? P power n plus nc1 P power n minus 1 Q power 1 plus nc2 P power n minus 2 Q square plus so on till what? NCR, general term I am writing, P power n minus R Q power R. Correct? Because NC2 means P power n minus 2 Q power 2 you are getting. So NCR means P power n minus R Q power R. Then it goes on till Q power n. This is what is called binomial theorem. Okay. Now how it relates to probability is the fact we are going to see now. Say for example that I have an event. Okay, I have an event for which the success is given by P, failure is given by Q. I know that the probability will always add up to 1. So P plus Q will be 1 always. Now, this is the probability of success and failure of the event on one trial. Now, if I do n trials, what will happen? If I do n trials, what will happen? Correct? Whether you do n trials, whether you do 10 trials, 100 trials, 1 crore trials, probability can never exceed 1 irrespective of value of n. Correct? Value of n. Whatever may be n, your probability can never exceed 1. That means if I do n trials, I will get something like this is equal to 1 power n. So now this can be expanded binomially and still the sum is 1. So if I do n trials, I will get something like this. NCR P power n minus R Q power R plus Q power n equal to 1. What it says is the probability on a n trial. See, always the power it adds up to n. n minus 1, 1. Again this is n. n minus 2, 2. This adds up to n. n minus r, this adds up to n. It adds up to n. So, every such component here says on a n trial, what are the combinations of success and failure possible. See, if I do 5 trials, I can get success in all 5 times, 4 success, 1 failure, 3 success, 2 failure, 2 success, 3 failure, 1 success, 4 failure, all 5 failures. That's what it is saying. Correct? So if I do n trials, I can have all success, you can have all failures. This is all failures. This is all success. N minus 1 success, 1 failure. N minus 2 success, 2 failure. Here, n minus r success, r failures. So these are the different combinations possible, and each such is giving that value. So each element gives the probability of, so this gives the probability of n minus r success and r failures. This element alone gives the probability of n minus 2 success and 2 failures. This element gives the probability of all success. This gives the thing of all failure. So this is what is your binomial distribution of probability saying. Clear? We will solve problem. We will make it more clear when we are solving problem. So this is the question. On toss of 5 coins, what is the probability of getting exactly 2 tails? Exactly 2 tails, at least 4 tails, at least 1 tail. Clear? This is what is the question. So let us solve part A. Solution. Let us solve part A. Now I am tossing 5 coins. I want to get exactly 2 tails. Now probability of tail on one trial is what? Is 1 by 2. Probability of, this is probability of, this is what is Q. I am sorry, P. Correct? Probability of success on one trial. Probability of not trial, not tail on one trial is what? That is nothing but probability of getting head, or it can also be found by 1 minus P, that is called Q, because P plus Q adds up to 1, correct? And this is 1 by 2. Now, probability of getting exactly 2 tails on 5 coins, because 5 coins are tossed simultaneously here. What is the probability that exactly 2 tails are obtained? Exactly when you can get 2 tails? First coin, last coin shows, middle 2 coin shows, any of the 2 coins shows tail, correct? Anything is possible. So the thing is, I want 2 tails out of the, so it's 5C2, any 2 of them can show tail, and probability of getting a tail is 1 by 2. Probability of not getting a tail is 1 by 2. The remaining 3 coins can show anything. Remember, this 2 always adds up to this value. This 2 should always add up to this value. Correct? So this is the required probability. This is nothing but 5C2 into 1 by 2 power 5. When we simplify, what we get? 5C2 will be 5C2 will be how much? 5C2, 5 into 4 divided by 1 into 2 into 1. 1 by 2 power 5 is 1 by 32. So it's 20 divided by 64, or it can be written as 116, nothing but 5 by 16. This is what is probability of exactly 2 tails on 5 coins. Correct? On toss of 5 coins. Okay. Now part B. At least 4 tails. Probability of at least 4 tails. At least 4 tails means what? I get 4 tail, 1 head, or 5 tails, 0 head. Always remember, I have been saying from first class, whenever OR comes, it translates to addition. Correct? So, I get this also I win, I get this also I win. Correct? But if I get 3 tails, 2 head, it's not considered to be win. Correct? So, what is the probability of this? Or probably this or this. So, out of 5 coins, I have to get tail on 4 coins and remaining 1 head, or this or becomes plus 5C5 into 1 by 2 power 5. This is the probability of tail, head, and 1 by 2 power 0. So what should I get here? 5C4 is same as 5C1, that is 5 into 5 by 32, because this is always 1 by 2 power 5 here. Correct? Observe that 4 plus 1 is 5, 5 plus 0 is 5. This and this always adds up to this value. Plus 5C5 is 1 into 1 by 32. So this will be 6 by 32. That is nothing but, if I cancel, it will be 3 by 16. Clear? Now part C is bit interesting. At least one tail. Probability of at least one tail. At least one tail means what? I can get one tail 4 heads, two tail 3 heads, three tail 2 heads, four tail 1 head, or five tail 0 heads. So I can find all these individual probabilities, and in between I get this or this or this or this or this, I win. So I have to find this and add it with this, then add it with this, then add it with this, then add it with this. So this is one way of finding it. Correct? Or the easiest way will be, total probability is always 1. We remember this, probability of E is nothing but 1 minus probability of E complement. If E complement, probability of E complement can be found easily, then probability of E can be found easily. Correct? So I can find probability of at least one tail as 1 minus probability of no tail. Correct? And this can be, probability of no tail will be what? So probability of no tail will be what? I have to get all 5 heads, 0 tails. Correct? So this expression will evaluate into 1 minus, I have to get all 5 tails. Correct? So 5 heads, all 5 heads. 1 by 2 power 0 into 1 by 2 power 5. Correct? All the 5 are heads, I get no tails. So this becomes 1 minus 1 by 32. This is nothing, the answer will be 31 by 32. So at least probability of getting at least one tail is 31 by 32 on toss of 5 coins. Clear? This is how we solve using binomial theorem. We will be solving more problems. See, this is again an interesting question. Probability of hitting a target with a missile is 25%. Okay. 4 missiles are fired. What is the probability that target is hit? This is what is asked. Now, target is hit. What is asked in the problem? First we need to understand that. That is more important. What is the probability that the target is hit? He is not telling anything else here. Target is hit even if one missile hits it. Correct? See, when I launch, see, the thing is, I have a target. I am firing 4 missiles, M1, M2, M3, M4. All the 4 are fired towards the target. Everything has a probability of 0.25 that it will hit the target. Okay. Now, the target is hit if this is hitting the target, or this is hitting the target, or this is hitting the target, or this is hitting the target. Means what? This and this can also hit the target. Like, ultimately what is asked is probability that at least one will hit the target. So probability that at least one will hit target is nothing but 1 minus probability that none will hit target. So this is nothing but 1 minus 4 missiles are fired. 0.25 is hit. 0.25 is hit. 0.75 will be the miss. Correct? Probability for one target. So none will hit the target means all will miss. Correct? So 4C4 into all the 4 misses the target and none of them hits the target. So 1 minus 0.75 is nothing but 3 by 4 the whole power 4. That is what is the answer. So if you solve it, what will you get? Minus roughly 68.36% chance that the target is hit. 68% chance that target is hit. Clear? This what it says. Clear? See the probability now. If you fired only one, the probability of hit was only 25%. By firing 4 missiles, you increase the probability that the target is hit to 68%. That is what is happening here. Clear? So this is another quick problem. Probability that a person knows English is 0.6. Find the probability that in a group of 5 there are exactly 3 English speaking persons. Clear? This is what is the question. So probability that a person knows English. So let me call that as probability of English. One person knowing English. One person is 0.6. This is my P. So probability that the person will not know English is Q, that is 0.4. This is one person not knowing English. Clear? Now let us proceed. Now in a group of 5, exactly 3 English speaking persons are there. Means out of 5, I want 3 guys to be English speaking. Any of them can be there. Exactly 3 English speaking. That means 0.6 power 3. And the remaining should not speak English. So this. So this is your answer. 5C3 into 0.6 cube into 0.4 square. So this will be what? 5C3 into 0.6 cube into 0.4 square. That will be 0.3456. It's an interesting number to observe. 0.3456. This is your probability that in a group of 5 there will be exactly 3 English speaking personnel. Clear? So this one is another problem. The probability that a part can be defective is 0.01. The parts are packed in pack of 10 and sold. The company offers a money back guarantee for the packs sold. That is, if more than one defective part in a pack, more than one defective part in a pack, money back claim is accepted. Okay, money back claim. That is, say for example, we take the part as pen. The probability that one pen is defective is 0.01, and the company packs this in packs of 10 and says that I give a money back claim if more than one pen is found to be defective. Okay, what is the probability that the company has to accept the money back claim for a pack? Okay, now let us solve the problem. What is the solution? Now, first we should understand when the company has to accept the money back claim. Company has to accept the money back claim only if there are more than one defect in a pack of 10. Correct? Yes or no? That is 2 defective, 8 non-defective, 3 defective, or 3 defective, 7 non-defective, or 4 defective, 6 non-defective, like that, all 10 defectives. In these cases only the company has to process the money back claim. Correct? So we can find each and every term individually, or we can use this probability of E is nothing but 1 minus probability of E complement. So company will not, and so 1 minus probability that the company will not entertain money back request, not accepting money back claim, So when the company will not accept a money back claim, 1 minus if there are 0 defects or 1 defect. Because the company is saying that there can be 1 defect. He is saying the company is giving you guarantee if more than 1 defect only he will accept the money back claim. So if there is 1 defect, he will not accept the money back claim. So what will be happening? 1 minus 0 defect, that is out of 10 you want to have 0 defect. Correct? 0 defect means 0.01. See, probability of every part, probability of defect is 0.01. This is given in the problem. Non-defect is 0.99 because total will add up to 1 always. Correct? So 0.01 power 0 and all the 10 are healthy. Or there can be 1 defective. Correct? This is defect. This is non-defect. 10C1 into 0.01 power 1 into 0.99 power 9. Observe that this plus this will always add to 10. Correct? 9 plus 1 is 10, 10 plus 0 is 10. This is again defective, non-defective. 1 defect is there. 0 defect is there, 1 defect is there. So when you solve this, 10C0 into 10C0 is 1 actually. So 1 minus 10C0 into 0.01 power 0 into 0.99 power 10 plus 10C1 into 0.01 into 0.99 power 9. If you solve this, you will get almost 0.005. Actually, almost you will get this 0.0047 something you will get. So the thing is approximately it is 0.005. So there is only 0.5% chance that company has to accept money back claim. For a pack of 10. Clear? Fine. One important point we need to understand the mean and variance of a binomial random variable. The mean of a variance is given by NP and variance of the is given by NPQ and standard deviation is given by root NPQ for a binomial random variable. Binomial random variable. Please remember this. There can be problems related to this. Where n is the number of trials, P is the success, Q is, this is the probability of success probability in one trial, and this is failure probability in one trial. Okay, and P plus Q will always add up to 1. Please remember this. So this is what is binomial random variable in short. Okay, now let us solve one more interesting problem. Okay, probability that, okay, let us solve this. X is a binomial random variable having mean to be four and variance as 4 by 3, what is the probability of success on at least one trial? What is the probability of success on at least one trial? This is what is asked. This is a very interesting question. X is a binomial random variable having mean to be 4 and variance as 4 by 3. What is the probability of success on at least one trial? Okay, what do I know? X is a binomial random variable. Let us observe what all is given to me. What is given to me? X is a binomial random variable. The moment X is a binomial random variable, its mean is given to me and variance is given to me. I know that mean of a binomial random variable will be NP and variance of a binomial random variable will be NPQ. So NP is nothing but 4. NPQ is nothing but 4 by 3. And I also know that P plus Q will be 1 always. Correct? So let us find what is N, what is P, what is Q first. Now, NPQ by NP will give me what? NP will get cancelled. It will give me Q. That means variance by mean will give me Q. So 4 by 3 divided by 4 is 1 by 3. This is what is Q. The moment Q is known, what is P? 1 minus Q, that is 2 by 3. Okay? Fine. Now, what is asked? 2 by 3 is P. Q has the value of 1 by 3. Okay. Now, what is N? N is nothing but mean. Mean is nothing but NP. So, N will be mean by P. That is nothing but mean is 4 divided by 2 by 3. This is nothing but 4 into 3 divided by 2. That will be 6. So, totally there are 6 trials. There are 6 trials. Okay. Probability of success on one trial is 2 by 3. Success, that is P, is 2 by 3. Failure on one trial is 1 by 3. Correct? So, what is the probability of at least one success on at least one trial? Means what? You have done 6 trials. What is the probability that you will have success at least on one trial? Correct? There can be what? 6 success, 0 failures. 5 success, 1 failure, 3 success, 2 failure, like that, 3 failure, like that, all things are possible. You are asking what is the probability of at least one success? That is what is asked. This statement is nothing but probability of at least one success. So, probability of at least one success is nothing but 1 minus probability of no success. Correct? This is nothing but 1 minus probability of all failures. So, this is nothing but 1 minus all failures means what? Out of 6, all the 6 times you fail. That is 2 by 3 power 0 into 1 by 3 power 6. This is success. This is failure. Correct? All the 6 times we fail. So, if we evaluate this, what we will get? 1 minus 66 will be 1. 1 minus 1 by 3 power 6. That's what we will get. 1 minus 1 by 3 power 6. If you evaluate this, what we are getting? We are getting the answer to be 728 by 729. This is the answer. So, probability of getting at least one success is 728 by 729. This problem is totally different. Please understand this. Okay, fine. So from we have seen binomial random variables. Now we are moving towards Poisson's random variable. See, the interesting thing, the problem with binomial random variable, first we should understand. Say for example, let us solve one quick example and we'll understand it. Say for example, we solve the first problem, right? 5 coins tossed, probability of exactly 2 tails. How we solve this? It is nothing but 5c2 into 1 by 2. You want 2 tails, 1 by the remaining 3 has to be heads. So 5c2 became 5 into 4 divided by 1 into 2 into 1 by 2 power 5. So this became what? 10 by 32 is same as 5 by 16. Correct. Now if it is 5 coins, you will solve like this. Suppose if I am saying 100 coins are tossed together. 100 coins tossed. What is probability of exactly 2 tails? So this will be 100c2 into 1 by 2 power 2 into remaining has to be heads. Correct? So this will be what? 100 into 99 by 1 into 2 into 1 by 2 power 100. So what you will get this as? We will get this to be divided by 2 power 100. This will be 3.9 into 10 power minus 27. I am not bothered about the number what you are getting. I am bothered about how clumsy this expression becomes. 2 power 100. Suppose I am asking you to find at least 50 tails. That's all. You are destroyed here. At least 50 tails means what? 50 tails, 50 heads, 51 tails, 49 head. Like that if you write. On either side if you go, it will be too much cumbersome and the expressions are very big and nasty. So for large n, binomial is not so good. So the answer is Poisson. Poisson's random variable. What Poisson's random variable says is lambda is the mean of the distribution, then probability of x equal to n is given by e power minus lambda power n by n factorial. This is what is Poisson's distribution says. Correct? See, when n is very large, binomial distribution becomes very, very difficult and Poisson's distribution. Okay, let me not use n here. Let me use some k here. Because this n and that n you should not confuse. Lambda power k divided by k factorial. That is where k is the required number of success. I am not bothered about the trial at all here. K is the required number of success. And lambda is nothing but lambda of Poisson's distribution is nothing but np of binomial distribution. So for large n, binomial will tend towards Poisson's only. Okay. So in case if large n's are given, instead of using binomial, find n and p and multiply them to get lambda and solve them by Poisson. This is the easiest way. Okay. Let us solve problems to enhance our understanding. So this is another problem. Probability of defect in a in part produced by a machine is 0.1, what is the probability that in a lot of 10 parts produced by a machine, at most one part is defective? Here see, the word used is very important. At most one part is defective means what? At most one part means what? At most one part means at most one defect means what? Zero defect or one defect. Correct? I cannot accept 2 defect or 3 defect or 4 defect like that. Correct? At most, maximum number of defects allowed is only 1. So it can be 0 defect or 1 defect. So probability of at most 1 defect is nothing but probability of 0 defect plus, or will always translate to plus, probability of 1 defect. Now, if I translate this into a problem in binomial variable, binomial distribution, how can I solve that? Probability of 0 defect in 10 parts will be what? Because probability of 1 defect is 0.1, probability of 1 non-defect is 0.9. For one, this is defect, this is non-defect of our 1 part. Correct? So for 10 parts it will be, I want 0 defect means 10C0 into 0.9 power 10 into 0.1 power 0. Correct? Or 1 defect means 10C1, out of 1 part can be defective, remaining 9 parts are non-defective, 0.1 power 1. Correct? So this will turn into how much? 10C1 into 0.1 power. So if you compute this, we will be getting how much? 10C0 is 1, 0.9 power 10 plus 10 into 0.9 power 9 into 0.1 turns out to be 0.7361. This is what I get if I use binomial distribution. Now, let us solve the same by Poisson. Poisson's way, if I solve by Poisson's way, what will I get? Lambda for Poisson's variable is nothing but NP. Correct? NP is what here? N is 10 parts. Probability of defect in 1 part is how much? Probability of defect in 1 part is how much? 0.1. So, this becomes what? 10 into 0.1, this becomes, lambda becomes 1. So, probability of at most 1 defect, this statement still remains the same. At most 1 defect is nothing but probability of 0 defect plus probability of 1 defect. And probability of x equal to k is given by what? By Poisson's e power minus lambda, lambda power k by k factorial. Correct? So if I translate this, I want 0 defect means what will I get? E power minus lambda, e power minus 1 into 1 power 0 by 0 factorial plus 1 defect is e power minus 1 into 1 power 1 divided by 1 factorial. If I simplify this, what will I get? 0 factorial is 1, 1 factorial is also 1, 1 power 0 is 1, 1 power 1 is also 1. So this is nothing but 2 e power minus 1. So what will I get? 2 into 0.7357. It's almost same. See, by binomial you got 0.7361. Here you are getting 0.7357. Almost the answers are same. Correct? So, when n becomes large, you see that the error will further reduce in case of Poisson's distribution. So this is how we are going to solve problems using a Poisson's distribution. We will solve few more problems. Okay. This is another problem. Probability of side effect to a drug is 0.001. If 2000 people take the drug, what is the probability that more than 2 will get side effects? Okay, see, observe that n is large here. N is large, that means go by poisson. This is what is the hint. Okay, whenever n is large, go by poisson. So what is P here? P is the probability of side effect, that is 0.001. So n is 2000. So lambda will be np, that is nothing but 0.001 into 2000, that will be 2. Correct? Lambda is 2. Now what is asked? Probability that more than 2 will get side effect. Probability that more than 2 will get side effect is nothing but 1 minus probability of less than or equal to 2 will get side effect. Correct? See, this is a discrete case. In discrete case, you have to be very careful. It is less than or equal to 2. Clear? So you will get 1 minus probability of less than or equal to 2 is what? Probability of 0 side effect plus probability of 1 side effect plus probability of 2 side effect. So what will you get here? 1 minus 0 side effect means e power minus lambda, lambda power 0 by 0 factorial plus e power minus 1 lambda power 1 by 1 factorial plus e power minus lambda, lambda square by 2 factorial. So e power minus lambda can be taken outside. E power minus lambda into lambda power 0 by 0 factorial will be 1 plus lambda power 1 by 1 factorial plus lambda power 2 by 2 factorial. So you will get 1 minus e power minus lambda is what? What is e power minus lambda? Lambda is 2, right? So e power minus 2 into 1 plus 2 by 1 plus 2 square will be 4 by 2 factorial is 2. So this is also 2. So it's nothing but 1 minus 5 e power minus 2. So what we will get this? If you substitute the values, means if you find the value of e power minus 2 here, you will get the answer to be 0.32. This is the probability of side effect, probability of more than 2 side effect. Clear? This is another interesting question. Average accidents in a week. In a week means what? In actually 1 week is 3. Correct? What is the probability that a given week will have an accident? This is the question. How to solve this? So, nothing is told to us here. It's pretty much very cleverly worded. See, only one thing is told very clearly to us is average accident is 3. That means the mean is 3. Only the mean is told to me. Nothing else is told. What is the probability that a given week will have an accident? What means an accident means what? At least one accident, correct? Given what is the probability that an accident will occur means what? Accident is considered to be occurred even if you have 1 accident. If you have 5 accidents also, if you have 10 accidents also, accident is considered to be occurred. Correct? What is the probability in a given week will have an accident? Okay. So, probability of at least one accident is what is asked. So, probability of at least one accident is nothing but 1 minus probability of no accident. Correct? Now, only the mean is given to me, nothing else is given to me. Only with the mean, how can I calculate the probability? The only way is Poisson. Because in Poisson, probability of x equal to k is nothing but e power minus lambda, lambda power k by k factorial. Correct? So, with only mean, I know what is the value of k here. K is no accident, right? So, k will be 0. So, e power minus lambda, lambda power k by k factorial I can calculate. So, probability of at least 1 accident is nothing but 1 minus probability of 0 accident. So that is nothing but 1 minus probability of 0 accident is what? I'm sorry. E power minus lambda, lambda power 0 divided by 0 factorial. So lambda power 0 is also 1, 0 factorial is also 1. It's nothing but 1 minus e power minus lambda. Lambda is given to be 3. So it will be 1 minus e power minus 3. So 1 minus e power minus 3 is what? Minus e power minus 3 is nothing but 0.9502. So 95% chance that accident will occur in a week. Correct? That's what it means. So a Poisson's distribution, please remember, mean is lambda, variance is also lambda, and probability that x equal to k is given by e power minus lambda, lambda power k by k factorial, and we will use this for large n, and lambda is nothing but np. On the other side we saw binomial. Binomial, what is mean? Mean is nothing but npq. N is the number of trial, p is success probability in one trial, q is failure probability in one trial. Okay, variance is nothing but npq, and what probability that x equal to k is given by what? nck p power what? P power k q power n minus k. Correct? We want to have k success. Probability of k success is given by nck p power k q power n minus k. Clear? Here this is how it works out. So please remember Poisson's and binomial distribution it will be very useful, and understand how to use the values given to find the mean. And also we saw problems in binomial distribution related to mean and variance are given, and we were asked to find the probability. We solved that. So we solved different models. So practice these type of problems. Okay.